Good afternoon to all. It is a great pleasure for me to welcome all of you for this session. On behalf of ISTE Staff Chapter, I welcome our Honorable Secretary Sir, respected Principal Madam, beloved Vice Principal Sir, HODs of various departments and faculty members. We are organizing staff seminar through ISTE Staff Chapter regularly. Today we are organizing webinar on a load balancing algorithm for the data center to optimize cloud computing application. Our resource person is Mrs. S.R. Kartiga, Assistant Professor, Department of Computer Science and Engineering. I hope that the session will give good content. Now I hand over the session to our resource person. Madam, Kartiga Madam, please take over the session, Madam.
Thank you, ma'am. Thank you for my introduction. Good afternoon to all. I am Kartiga from CSE department. So I'm going to take webinar about load balancing algorithm for data center to optimize the cloud-based application. Nowadays, most of them are familiar to the cloud-based application. We are using many cloud-based application. The main objective of this paper is to optimize the delivery performance and IaaS of the cloud computing. It is mainly achieved by load balancing. The load balancing is nothing but scheduling a task to the available resource. So in this paper, they proposed the load balancing algorithm to allocate the client resource among the virtual machine, and they using some techniques to find the violation. If any violations occur, they allocate the resource, they migrate the task to the available resource. So this is the main objective of this paper. Next, introduction. We know that the cloud computing is a on-demand service to the client. So cloud service provider provide the three types of the service. The one is infrastructure as a service, the next one is platform as a service, and the final one is software as a service. Load balancing is mainly take place in the infrastructure as a service, because infrastructure as a service is always handle the backend, whereas handle the server, data center, and the virtual machines are always managed in the infrastructure as a service. So efficient allocation of your task to the virtual machine is a crucial process in the cloud computing, due to the limited numbers of resource or the virtual machines. So usually the resource allocation in IaaS is deal with the balancing the resource provided to the client and balancing your user request to the server. So in this paper, they used the load balancing algorithm called cloudlet scheduling time shared algorithm. This algorithm uses the three parameters. The one is make span time, the another one is deadline in SLA, and the third one is completion time. So make span time is mainly used to calculate the time of scheduling. It's a time taken to schedule your task, and it is also used to find the latency. Latency is nothing but the time delay between the sending the client request and receive the response from the server. The second one is deadline in SLA. SLA is a service level agreement. So service level agreement is nothing but it just a document shared by the cloud service provider to the cloud user. The main parameter in the SLA is deadline. The deadline is nothing but that maximum time taken to execute your task. That is called deadline. And the final one is completion time. The completion time is the time taken to execute the specific task. The next one. Usually, the load unbalancing issue in IaaS is take place due to the cause of inappropriate scheduling the process to the virtual machine, and inefficient mapping of your task to the appropriate resource. And then third one is unequal distribution of tasks to the resource. Because of these three reasons, the load unbalancing is take place in the infrastructure as a service. This is the normal architecture of task scheduling in the infrastructure as a service. The first one is cloud user. The cloud user send a request to the virtual machine through the cloud broker. The cloud broker is also known as a cloud agent. The cloud agent is simply a software application. It's mainly used to distribute a task between the different cloud service provider. Then this request are submit to your virtual machines, and the cloud service provider usually maintain the quality of service in every model to ensure that your task is completed with the specific deadline. So efficient load balancing algorithm is take place in the cloud agent. um, After that, the cloud computing is mainly depend upon the your virtual machine monitor or the hypervisor. The hypervisor is nothing but it is a process to execute your multiple virtual machine in a single unit. So using this virtualization, we can easily mapping a task to the virtualization technique. We can easily mapping a task to the virtual machine. Next, proposed framework. In this framework, it consists of the two layer. The one is a top layer, the another one is the bottom layer. In the top layer, the client send a task, more one or more tasks are sent to the virtual machines, and using the cloudlet based time share algorithm, they sharing the task to the virtual machine. They're using the three parameter, like I already said, that takes span time, deadline, and the completion time. By using the three parameter, they allocate the resource to the virtual machine. In the bottom layer, they they what they in the bottom layer, after the resources um, submit to the virtual machine, it the virtual machine status is set. That means it's set. If it is a high priority, um, then the high priority means nothing but your completion time is higher than the deadline. So it means if completion time, your task completion time is higher than the deadline time, it means the violation is occur. Then the violation is occur, our load balancing algorithm is used the migration technique to transfer the load to the available resource. They reallocate the relocate the task to the resource by reconfiguring the MIPS. MIPS means multiple instruction per second. The multiple instruction per second is the amount of work is done in your computer. In this bottom layer, the first one is virtual machine. The MIPS is 635. The completion time is 3015, and deadline is 3256. So it is available to available for the task. But in the second virtual machine, your deadline is MIPS is 635, and the completion time is 3817, and the deadline time is 3256. So the completion time is exceed your deadline time. It means the violation is occur. Next, your workload is migrate to the available resource of virtual machine 1. After that, I already explained the top layer and the bottom layer. Now, the proposed algorithm, the steps of the load balancing algorithm. First, in the first step, the cloudlet. Cloudlet is nothing but it's just a task. The request is sent to each virtual machine. The request is sent based on the arrival time. Always the task has the length, deadline, completion time, and finally the arrival time. It checks the completion time for each task against the total number of the tasks. If it is exceed the deadline, next the violation is occur. The process is take place. It will reallocate your resource to the available virtual machine by reconfiguring the virtual machine priority. Usually the completion time, expected completion time, is calculated by taking the task length of each task, MIPS, million instruction per second, and divided it by the virtual machine MIPS. So by using this, we can easily calculate our expected completion time and then find out whether our completion time is exceed our deadline or not. And then, so this is the make span time. I already explained that the make span time is, it's the time to calculate the task, calculate the scheduling of a task. So this is the equation for the make span time. MT is your make span time, maximum CT is your cloudlet completion time, cloudlet is your task, so task completion time. MT average, we can calculate the MT average, summation of maximum cloudlet completion times divided by n is the total number of virtual machine. After that, execution time is the time taken to complete your task. The equation for the execution time is execution time equal to actual CPU time. So to find the execution time average, the summation of actual CPU time divided by total number of cloudlets, that is number of the task. Then the resource utilization. In the resource utilization, RU is the resource utilization. Resource utilization is how efficiently you can use your resources. That is the virtual machine server. So RU equal to execution time divided by make span time, and to find the average, RU average equal to execution time divided by make span time into 100. By using this equation, we can easily calculate our make span time, completion time, and the resource utilization. And by getting the result of this equation, we can easily find the completion time of each task, and we can find the whether our task is exceed the deadline time or not. If it is exceed, we know that then our violation is occur, then we can allocate the task to the available resource. If it is not violated, then the state is in successful state, so the task get scheduled in the correct way. So at the conclusion, in this paper, by using a load balancing algorithm, we can efficiently schedule a task by reducing the execution time and increase the ratio of the resource, that is the server, in the cloud-based application. Thank you.
Hello,
Madam,
ma'am.
thank
Finish,
you
ma'am.
for your presentation, madam.
Okay, ma'am. Any questions?
No, ma'am.
Okay, ma'am.
This is to time to propose vote of thanks. First, I would like to thank our management and secretary sir for encourage us to organize such programs. Next, I would like to thank our principal madam for giving guidance and support for us. Our wholehearted thanks to our resource person, Mrs. S.R. Kartiga, Assistant Professor, Department of Computer Science and Engineering, for presented good content on a load balancing algorithm for the data center to optimize cloud computing applications. Also, I thank Vice Principal Sir, HODs of various departments for their support. Also, I thank you to all faculties here for joining with us. Finally, I thank Mr. J. Niranjan Samuel for giving technical support for us continuously. Once again, I thank all of you on behalf of ISTE Staff Chapter. Thank you.
Thank you, ma'am.